We're back with the 2015 AP exam. This is question number 5, and this is a pretty easy question right here. It looks kind of complicated, but it's not that bad. We're told to consider the function. I always like it when they tell me to consider something. I've considered it, and I'm done with it. Just teasing, of course. Consider the function f of x equals 1 over x squared minus kx, where k is a non-zero constant. And they give us the derivative of the function as well. That's nice, they gave us the derivative. Part A says, let k equal 3, so that our function equals 1 over x squared minus 3x. Write the equation of the tangent line. Man, you were wondering, where am I going to see tangent line again? At the point whose x-coordinate is 4. So we've been writing tangent lines for a while. We know we need a point. So we're going to need f of 4. And I just plugged it in. 1 over 16 minus 12, and that's just 1/4. We need our derivative, our slope, f prime of 4. I'm going to plug it in. Now you got to remember, you got to plug your k back in, so they already gave me the derivative. I just got to plug k in. So this is going to become 3 times 2x is 4 over 4 squared, which is 4 squared and 16 years ago. Sorry, every math teacher has to do that. 16 minus, and this becomes 3 times k, 3 times 4 squared. And if I simplify the top, we're going to get 3 minus 8, which is negative 5. Oops. And on the bottom, 16 minus 12 is 4 squared, that we get 16. So there's my slope. So my tangent line, y minus 1/4 equals negative 5 over 16 x minus 4. And there's my tangent line right there. Pretty easy to do. Very straightforward. You're going to get a point for your slope and a point for your tangent line. 2 points very quickly. All right. Part B says, Part B is asking, let k now equal 4 so that f of x equals x squared over 1 over x squared minus 4x. Determine if f has a relative minimum or relative maximum, or neither at x equals 2. So I'm thinking first derivative test, since they already gave it to me. The first derivative test. Now, think back to what we did for a question number 4 real quickly. They also asked us to find a relative maximum minimum, but it didn't even have a critical number at the x value they were looking for. So you have to make sure that, one, we do have a critical number. So that's the first thing. We want to first find f prime of 2. Okay? Remember, we're plugging it into our derivative here. So f prime of 2. K now is 4, don't forget. So it's 4 minus 2 times 2. And I'm done. This becomes 4 minus 4 times 2 squared. But I'm done. The top there is already 0, so therefore this is a critical number. So to determine if this is a relative maximum, I am going to use my sign chart. My critical number is 2. So my critical number is 2, and I'm going to check it. F prime and F. Remember, F prime is our rule. This is going to be 4 minus 2x over x squared minus 4x squared. Now the bottom is always going to be positive because we're squaring it. I just need to plug in a number before 2 and after 2 in the top. So if I let x be 0, I'm going to get a positive here, so it's increasing. Plug in a number after 2 like 3, that becomes a negative, so it decreases after 2. So therefore x equals 2 is a relative maximum. So we can say f of 2 is a relative maximum. And the reason for that is because the derivative f prime of x goes from positive to negative. Oops. Almost did positive again. Positive to a negative. Doesn't take that long. It's a good review of the first derivative test. So how do they point this one out? You get 1 point for determining if it's a critical number and 1 point for your answer. Now you might be thinking, but what if I don't have my sign chart? Do I lose points? You could. The AP, they want to see your work. They want to see your justification. They don't just take guesswork. It's a critical number. It's a maximum. You have to have something to justify it. This must match your answer to get that full credit. So if you don't have your sign chart, you can lose this full credit right here because you have nothing to back it up. They'll think of it like, oh, they just guessed. So always check always have your sign charts there to back up your work. All right, question number 5. Find the value of k. Find k. Now they've been giving us k, so now they're asking us to find k, for which we have a critical point at x equals -5. So they're telling us that this is a critical number, so that f prime of -5 is 0. And I can use that for my rule up here, ready? Remember, f prime of x, remember, is given by this, k minus 2x over x squared minus kx squared. And we want to find k, and here's what we know, that this is going to equal 0 if x is -5. So we're going to plug all of that in. So k we don't know, minus 2 times -5. Remember, we're looking for f prime of -5 over -5 squared is 25 minus k times -5 squared. And we know that that's going to be 0. I don't really have to worry about the bottom because I'm just going to cross multiply. So what's k going to equal? -10. Doesn't take that long to do that one. Not worth too many points because I'll just plug and chug, really what it is. It's only worth 1 point. All right, now here's where the bulk of our points come from. Part D. Okay, this is going to be fun. Let k equal 6 so that f of x equals x squared over 6x. Find the partial fraction decomposition for the function of f, and then find the integral f of x. So they want the partial decomposition. So basically we want to integrate 1 over x squared minus 6x dx. This is partial fractions. That's what that is. So when we integrate this, we have to use our partial fractions. So let's go ahead and review that. To do partial fractions, we're going to factor the bottom. So we would get 1 over x times x minus 6, and that's going to equal a over x plus b over x minus 6. Cross multiply by the LCD, we get 1 equals a times x minus 6 plus b times x. My zeros, remember, this is our Heaviside method. Heaviside that we can pick any values for x, make this true. We just have to do it twice to solve a system of equation, or we said, hey, look, you know, I'm just going to let x be the zeros, just to cancel things out. If x can be anything. So if I first let x be 6, this becomes 1 equals, that's just 6b. B, so b equals 1, 6. If we let x be 0, we're going to get 1 equals -6a, so a equals -1 over 6. So that's our partial decomposition right there. So this new integral becomes, what is a? -1 over 6 times x plus b, which is 1 over 6 times x minus 6 dx. Now this is pretty easy. This is our natural log stuff. The antiderivative of 1 over x is natural log of the absolute value of x plus c. Now, so when I integrate here, I'm going to get -1/6. It's just a constant times the natural log of x plus 1 over 6. This becomes the natural log. Again, that's just a constant, natural log of x minus 6 plus your constant of integration. Now, if you want to, you can leave it like this. That's fine. If you want to simplify it, this becomes 1/6 natural log of x minus 6 over x plus c. You can write it like that if you want. So how many points is this one worth? This is worth a lot. Just your decomposition is worth 2 points, right? So rewriting it, and then your antiderivative is worth 2 points as well. Please don't forget your constant of integration. All right, that's question number 5. Go on to question number 6. That is the series question. I guess you could say we're pretty serious about this one. I'll see you soon. Bye-bye.